Hello and welcome to our notes for Module 2.1. We're going to be talking today about translations, and this is page 63 if you would like to pause your video and get caught up. Ooh, sorry. On page 63, we are talking about translations, and you can see at the very top of the page, it says a translation slides all points of a figure the same distance in the same direction. Let's circle same distance and same direction or highlight those. If you are using highlighters at home, a translation has to move each point of the figure the same distance in the same direction. Otherwise, you won't be moving an identical figure. Your figure will get warped if you don't move each point the same distance or the same direction. To show an example of a translation and how it's done, we have this little illustration, and triangle ABC is the original triangle, and it's going to be moved this distance in this direction is represented by segment XY. So as you can see, segment XY is copied onto every corner, and those corners, the A prime, B prime, and C prime corners, are then connected to make a new triangle. If you have these two triangles here, triangle ABC is going to be called the pre-image, while triangle A prime, B prime, C prime is going to be called the image. It's important to know which triangle came first. Otherwise, your direction could get backwards, and then you could get the whole problem wrong, even though you really understand the basic concepts. The pre-image is the image that came before. You can see pre as this prefix. Pre usually does mean before, so that might help you remember which one came first. It's the one that has pre in it. The image is the one that came second. If you look really similar to somebody else in your family, maybe a parent, maybe a sibling, maybe a grandparent, you might have heard, if you've lived in the South very long, that you are the spitting image of that person. The image is the one that came after. So the pre-image is the original. The image is the same figure, but after a transformation of some kind has been done. In this case, translations. On the next page, one of the types of translations that we can do is by using a vector. A vector is indicated often with a lowercase script letter, and then this little interesting half arrow symbol above it. The definition of vector over here in the reading says a vector is a quantity that has both direction and magnitude. A vector's initial point is the point where it starts, and its terminal point is the point where it ends. So the initial point of vector V would be E, while the terminal point of vector V would be point F. So you can name the vector EF, or you can name the vector vector V. Please notice that when you have this little half arrow, your terminal point needs to go underneath that arrow. You can see we're moving it from E over to point F, and that's what's also indicated in our name. It starts at E and it moves toward F. You might be thinking that you've heard of a vector before, and you probably have. Let's see if you have heard vector in the same place that I have. Follow along in your book to see how his description matches.
I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector. See, as I'm committing crimes with both direction and magnitude. Oh yeah!
So good job, Pixar. I guess Pixar came and looked at our geometry textbook when they were writing those lines, because a vector is a mathematical term for a quantity that has both direction and magnitude, just like the crimes that Vector was committing in Despicable Me. And a vector is a type of a translation because direction and magnitude are really kind of the same thing as distance and direction. You can see direction, those are going to line up. Magnitude is really just an amount. It's a more general quantity that means an amount, whereas distance is the more specific term that was used on the previous page. So a vector is a type of translation. The way that you draw and represent a vector, you could choose to take each point and draw or replicate the original vector going from the original or the initial point to the terminal point to make a translation. That is one way that you could do that. If you were to do so, all of the vectors that you drew would end up being parallel with each other. That line would be parallel with this line, would be parallel with this line, and it would be parallel with our vector down here as well. And that's because parallel lines are always the same distance apart. And so if we're taking lines and we are making all of these lines go the same direction and the same magnitude, or the same distance and same direction, then it makes sense that they should never intersect and they would be parallel. One way, actually, let's just practice doing that. Let's practice. So we have this vector, and we could copy this, but really when we copy it, we need to know how many spaces up or down, left or right, we're doing that. And the way that we do that is with these angle brackets. And angle brackets are going to have these two places inside, and it's going to kind of mimic our coordinates for a point. So the X amount of change is going here, and the Y amount of change is going here. So we're going to start at our initial point and end at our terminal point, and our X's go 4 spaces to the right. Well, that's a positive change, so we're going to put +4, or just 4. The positive is understood. Then we're going to check the change in height, in Y value. We go up 2, well, that's a positive change also, so we're going to put a +2 over here in this bracket. And this is called component form. Component form gives you the specific direction and magnitude rather than just a visual drawn by this line. Personally, I prefer to use the component form because that's all I'm going to do here anyways. I'm just going to count how many spaces up or down, left or right, and then I'm going to repeat it from corner A and from corner B and from corner C. So if I have the component form rather than just vector V drawn, it actually kind of saves me a step. So what we'll do to translate triangle ABC along vector V is we will figure out where our terminal points need to be. So I'm going to go right 4 and up 2, and I'm going to put A prime because that's the new name of this point. It has been moved. My vector looks like that. We need to use the same vector for initial point B. We're going to go right 4 and up 2. This makes B prime because we translated that along vector V. Lastly, point C, we're going to go right 4 and up 2 to point C prime, which has been translated along vector V. Let's connect all 3 of these, A to B, A to C, and then B and C. And you can see it kind of looks like a 3D triangle, but what you have is in the back here, you have your pre-image, which is triangle ABC. And then on the top, because that's how our vector moved things, we have this other triangle, triangle A prime, B prime, C prime, and it is the image of triangle ABC after a translation along vector V. There are several different ways that we could know that A prime, B prime, C prime is the changed version, the image rather than the pre-image. The first of those is to look for the prime notation. This little apostrophe up here means prime, and those points will let you know that that is the changed version. Some kind of transformation has been done to turn A into something else, A prime. It moved its location. The second thing you could look at is you could look at the arrows. The arrows start on C, for example, and they end up here at C prime. And so that's another way that you could identify from the drawing, if it were completed for you, you could identify which one was the pre-image and which one was the image. Let's do an example on our own. Let's translate trapezoid ABC along vector V. And just to be clear, these don't all have to be vector V. You could have vector C, you could have vector D, you could have vector any letter. They're just using V a whole lot. Now, personally, I like to go ahead and find the component form. So I'm going to start with that. So my X directions, I go left 3. Left in the X direction is a -3, so I'm going to decrease my X's by 3. For Y's, I'm going up 5, so that's going to be a +5. So my change is -3 in the X's, +5 in the Y's. So I'm just going to change A and B and C and D, each one by one, according to this vector down here, which is also the same as vector V up here. So left 3, had to scroll up, there it is, A prime. B to B prime, left 3, and up 5. That's the neighbor's dog, good times. From C to C prime, we still go left 3 and up 5. This is now C prime. From D, we go left 3 and up 5, and we have D prime. Let's connect all of our points. And we have translated A, B, C, D according to vector V.